In order to find the extreme values of this function, we need to do the first derivative test. The first derivative test will tell us where it's increasing and decreasing, and from there we can make decisions about extreme values. To run the first derivative test, we first need critical points. Those will be endpoints of the interval, if any. So from this case, we have two endpoints, 0 and 2 pi. We can also get critical points where the first derivative equals 0 or where the first derivative does not exist. So let's look at this first derivative. The first derivative of h prime, is the derivative of sine, which is cosine, and the derivative of cosine is negative sine, so minus negative sine is plus sine. We are interested in where that first derivative equals 0. It will never not exist. I know that's a double negative, but cosine and sine both exist for all values of x, so there's no value that we could have here, no opportunity to divide by 0, have any kind of funky thing happen. So we don't have that possibility, but we do need to find where cosine plus sine equals 0. And right now that might be kind of a tricky thing to wrap your head around, so let's change the question to where sine is equal to the negative cosine. Well, now you might sort of be thinking about places where sine equals cosine, but negative in sine, negative in value, but still not quite a very clear question. Let's divide both sides by cosine. Then you have sine over cosine equals -1, and sine over cosine is none other than tangent. So now the question is, where is tangent equal to -1? Here's a little sketch of the unit circle, and the only places where tangent equals 1 are at pi over 4, where the sine and the cosine values are the same. And you might get there already from this part of the line where sine and cosine equal each other, but now we need the tangent to be negative, or sine to have the negative value of cosine. Tangent is negative in all students take calculus, tells us where all the trig functions are positive. So tangent will be negative in quadrant 2, right here, and also in quadrant 4. So we need those two values for x as critical points. That first one is 3 pi over 4 before we get to a full pi, and then just shy of 2 pi, which would be 7 pi over 4. So altogether now we have 4 critical points, 0 and 2 pi, and then 3 pi over 4 and 7 pi over 4. Let's use those critical points to cut up the intervals of this function. So 0 and 2 pi are the endpoints, and we have 2 critical points on that interval, 3 pi over 4 and 7 pi over 4. Next we're going to test and use the first derivative test to see what the behavior is of this function on these intervals. So I've rewritten the first derivative there. We're going to test that at a point here, at a point here, and a point here. So we need some number between 0 and 3 pi over 4. A very good place there would be pi over 2. Alright, so h prime, the first derivative at pi over 2, is the cosine of pi over 2 plus the sine of pi over 2. Cosine of pi over 2 is 0, sine of pi over 2 is 1, so this value is 1. 1 is positive, that means the function is increasing on that interval from 0 to 3 pi over 4. Let's test between 3 pi over 4 and 7 pi over 4. A good place to test there would be pi. So we have the cosine of pi plus the sine of pi is -1 plus 0, or -1. That means the function is now decreasing on that interval. And we need to check somewhere between 7 pi over 4 and 2 pi. Now this is kind of a tight interval, so we don't have a lot of options in there for nice values to choose. The only good one we have is 11 pi over 6. That number is between those two. So we have the cosine of 11 pi over 6 plus the sine of 11 pi over 6. So the positive square root 3 over 2 minus the y value of 1/2. So that's the square root of 3 minus 1 over 2, which I might need to approximate with the calculator just to be sure that I know the value of that. I do think that the square root of 3 minus 1 will be positive, divided by 2, so we should have a positive value. Yeah, we can be sure about that, right? Because the square root of 1 would be 1. So the square root of 3 must be bigger, so we have some positive value here. Now we're ready to make our decision. For our fourth step is just to decide, just to describe what we see here. We see that the function is increasing from 0 to 3 pi over 4, and again from 7 pi over 4 to 2 pi. We also see that the function was decreasing from 3 pi over 4 to 7 pi over 4. That's where that first derivative returned negative values. Now what about the maxes and the mins? So let's see, where we were increasing then decreasing, we must have a max. When decreasing then increasing must be a min. But this is a closed interval, so at 2 pi we have another max, yet another because we were increasing until that point, and at 0 we have another min because we were increasing after that point. So now we have to decide which ones of these maxes and which of one of the mins are absolute and which are relative. So to decide that, we need to evaluate the function. Decide who is absolute based on y values of the original function. Get this junk out of there. So we're going to take that original function way back at the beginning. Remember h was sine minus cosine. And we want to compare the mins and the maxes. So let's first see who's the biggest minimum. Or the smallest minimum, I suppose. The minimums were 0 and 7 pi over 4. So at 0, we get the sine of 0 minus the cosine of 0. Sine of 0 is 0, cosine of 0 is 1. That value is negative 1. And we can also try 7 pi over 4. The sine of 7 pi over 4 minus the cosine of 7 pi over 4. Sine of 7 pi over 4 is negative square root 2 over 2, and the cosine of 7 pi over 4 is positive square root 2 over 2. So that's a negative square root 2. Well, which one is bigger? Or smaller rather, because they're minimums. And the absolute minimum would be this one, because the square root of 2 is larger in value, in absolute values. This is the absolute minimum, smallest of the two values, and at 0 we have a relative minimum. Then let's try the maxes to decide which of those is absolute. We have two values of maximums, 3 pi over 4 and 2 pi from way up there. So now we're going to test those into the original function. H of 3 pi over 4 is the sine of 3 pi over 4 minus the cosine of 3 pi over 4. Sine of 3 pi over 4 is square root 2 over 2, that's positive y value, and the cosine value is negative square root 2 over 2 for, again, the positive square root of 2. That's 2 square roots of 2 over 2. And at 2 pi, we get the sine of 2 pi minus the cosine of 2 pi. Sine of 2 pi is 0, cosine of 2 pi is 1, so that's negative 1. We're looking at maximum values. The absolute max is the largest of this value. That must be the square root of 2. and -1 must be a relative maximum. So we'd finish these up in way back up here where we had our summary, and absolute max we just found at 3 pi over 4. This one was the absolute, this one was relative, and an absolute minimum was at 7 pi over 4 with a relative minimum at 0. So absolute minimum x equals 7 pi over 4, relative maximum at x equals 2 pi, relative minimum at x equals 0. Then we have exposed with the first derivative test for extreme values everything we know about the function.